Hey everybody, and welcome to this amazing new feature on Zoom, a fantasy feature called Zoom Past. Zoom Past what? Well, they're now offering a service, possibly, using a special AI, quantum, I'm being funny, feature that allows you to talk to people who have passed in the past. So I thought, who would I really like to talk to and ask questions and clear up a few points? And I thought immediately, Robert Watson Watt would be amazing, the so-called inventor of radar and an amazing scientist who built Chain Home and went on to do lots of different things and could possibly answer some questions about the death ray and even Rendlesham Forest. I'd love to have his views on that. But sadly, Robert passed away in 1973. But that's not a problem anymore because using this fantasy AI quantum machine, I'm being flippant here, on Zoom, I can actually talk to Robert. So I've come up with a number of questions that I'd like to ask Robert Watson Watt. And so today, let's go back in time using this special new feature and actually talk to Robert Watson Watt. Hey, Robert. It's an honor, sir, to actually talk to you. You're a real hero of mine, and there's so many things that you've done in your life that I'd like to ask you your personal details of, actually, to clear up points. I mean, you've written books, people have written biographies about you. We all know about direction finding, and there's lots of things that are still mysteries. So, hi, Robert. Hey, Simon. And yeah, it's great to speak to you. This is amazing. Great. Yeah, I was born in 1892, and sadly, I left this mortal coil, but I'm still around on Zoom in 1973. I'm very intrigued to actually hear what you want to ask me. Yeah, if I can be on modern YouTube and answer some questions, that would be great. So far away. Excellent, Robert. That's great. I'm so honored to be here with you. So let's talk about your early career. Where did you start? Where were you working when you were contacted by the MOD? Oh, I'd love to tell you. Simon, I was up in Dundee working for the Met Office, the people who do the weather. But specifically, I was a scientist, and my real interest was in building a lightning tracker. And I noticed that lightning made wee flicks on radio equipment. And I was fascinated by something called the ionosphere, a layer of our atmosphere. That was very much my research. In Dundee at the time, I was only in my early 20s. So while you were at the Met Office, did you know about Nikola Tesla? And did you know that Tesla had actually come to the UK and visited Neville Chamberlain to sell the UK, I guess, his defensive shield called the Death Ray? Oh, Nikola Tesla, a real hero of mine too. Yeah, yeah. I mean, we'd read in the newspaper all about this so-called death ray, and to be honest, it was pretty secret when Tesla came to visit Neville Chamberlain. And this, you have to remember, was just before the outbreak of World War II, and Britain was very much an island nation, and potentially was a real good use of a protective shield if only our coastlines could have some kind of defense. So it was a good idea of Nikola Tesla's. I never knew really how it worked at the time, but Neville Chamberlain wasn't interested in it. He was interested in doing peace in our time and doing a deal with Adolf Hitler. He really remembered the horror of World War One and didn't want another war at any cost. But a defensive system might have been good, but you also have to remember, in 1930s, Britain had just been through a terrible depression, and really even the government in Britain didn't have the money that Mr. Tesla actually wanted for his death ray. Plus, it had never really been proved to work. Oh, great. You'd heard of Nikola Tesla's visit to Chamberlain, and
Fantastic, Robert. But did you know that the British security services went into Tesla's hotel and stole the death ray plans? Ooh.
Oh, I never heard about that.
Mm.
It could be true because the plans certainly were made available later, in fact, to me. So I always wondered where they got them from, but I was certainly not party to any of that and didn't know really what was going on at the time.
Oh, Robert, I'm sure you weren't. You were a weatherman in Dundee at the time and wouldn't have known that British government had stolen Tesla's plans. But later on, you realized that the plans weren't complete. Is that correct?
Aye, good point. When eventually the
Mm.
plans did come to light, wherever they got them from, I assume clandestinely, they were seem to be complete, but in fact they're not. There's a missing part of Tesla's death ray plans that Britain got hold of, and that was how to power it. And that was a big conundrum.
But you got contacted by Henry Tizard from the War Office, who was looking for somebody who knew about radios and the ionosphere and propagation of signals. Tell us about that, Robert.
I, Henry Tizard, contacted me through my office. I seemed to be a good fit. I knew about radio. I've looked at the ionosphere. I could see things at a distance, like lightning strikes. Maybe somehow I could put together radio, the ionosphere, and a death ray. It was fascinating, but it was a bit of a challenge.
Great. So you took the Queen's shilling and you were given a grant, I think, to set up an investigation using the stolen plans of the death ray. And so what did they give you? Where were you set up? Where did you actually do this investigation into whether the death ray might work?
Well, that's true. It was a very small project with a very
Mm.
small grant, and they gave us a very small hut at a place in the middle of nowhere called Orford Nest. They'd used it for bomb testing. It was a War Department range out in Suffolk. I didn't know it very well. It's just a shingle spit and a long way from anybody. There's nobody lives there. You have to cross over to the Orford Nest on a boat. The surrounding towns were great. I loved being in Orford village. Fantastic hub. And so initially just me, and then I got to cherry pick a few of my Met Office team, leading guys who knew about radio, and we looked at Tesla's plans and scratched our head. And while we had the resources
Mm.
of
Mm.
the Navy, they had big radio tubes, vacuum tubes, and things, and we thought we'd try and put one together, build Tesla's death ray. But it proved very hard.
So what did Henry Tizard ask you to do? I mean, obviously build one, make it work, but how are you going to demonstrate it to the British government?
Well, the War Department came up with this crazy
Mm.
plan. Along with us in our wee hut on Orford Nest, there was a flock of sheep, and we were tasked with could we kill a sheep at 200 yards using radio frequency? And we never killed a sheep. I like sheep, but that was Henry Tizard's plan that if we could actually kill a living organism at a distance, it would at least prove it did function at some level.
Oh, I'm pleased that no sheep were harmed, but also I guess you didn't get it to work. What was the issue with the plans? I mean, you said earlier that it was missing the power supply. Talk to me about the death ray and how hard it was to actually build a working device.
That's exactly what we found. The plans were pretty complete, although it was very exotic technology. Later on in my life, it became obvious that it was a particle accelerator. At the time, we didn't even know what subatomic particles were. We were looking for electric bullets. But in principle, I understood how it might work, but it didn't work. It didn't work in any way whatsoever because there was no way to make enough power to fire the wee beastie at the beasties. I mean, it's just not going to work. I mean, later on in life, with nuclear power that I learned about, the end of my life, it would become possible that it could work. But back in the 1930s,
Mm,
you know,
mm,
we just didn't
mm,
have enough energy to actually produce subatomic particles that could fly across orphan nests and harm a wee sheep. No, it didn't seem to work at all.
Oh, good and bad. Good for the sheep, I guess. So, you had to tell Henry Tizard the bad news that Tesla's plans of the death ray did not work.
Yes, he came up and he sent people up to orphan nests,
Mm,
and we had a pint, and it obviously wasn't going to work. I don't know. The principle was kind of interesting though, because it was all about seeing things at a distance and maybe at low level power, and maybe related to my earlier work at looking for discharges from thunderstorms. It was possible to find a direction of something like a thunderstorm. But of course, this was leading up to World War II. And if we weren't going to make a death ray work, wouldn't it be amazing not to only have a defensive weapon, but to have some way of knowing if the island of Britain was ever under attack from
mm,
airplanes?
mm,
And that got me looking
mm,
at other papers that had existed, and this is really important, and that's something that people often don't know about me. I did a lot of research into whether radio could bounce off aircraft. And that led me down a very interesting direction.
It's such an honor to talk to you. I mean, it's great because, I can actually ask you about the birth of what later on became radio direction finding and, the Americans named radar. So Robert Watson Watt, did you invent radar?
I'm glad you asked me that. No,
Mm,
I didn't invent radar. Radar already existed. There's some very, very smart scientists in Ukraine that was part of the Soviet Union who invented radar.
Oh, that's a turn up. Everybody in Britain thinks that you did invent radar, but in fact, it was already invented.
It was. I mean, Britain didn't
Mm,
have it, but there was a working system actually used in the Soviet Union from a research laboratory in the Ukraine that proved that you could bounce microwaves off a metallic object, an airplane, and you know. Somehow those plans came to me through the British government, and although they weren't ours, it was worth me looking at whether Britain could actually make our own version. But Britain already knew about this in a really interesting report that had been kicking around for a while. The BBC, I think it still exists today.
mm,
Um,
mm,
Maybe less people watch
mm,
it, but at the time, the BBC was so important, transmitting radio, of course. And one of their biggest transmitters is in a place called Daventry. And they were
mm,
having a problem. These newfangled flying machines, quite near an RAF base near Daventry, were taking off and flying through the BBC radio beam and causing it to wobble. So listeners to the Home Service would lose their signal, and Mrs. Dale's diary wouldn't be heard clearly. And they wrote to the BBC and said, "Why is your signal wobbly?" Now, the BBC never owned their own transmitters. They don't to this day. It's part of the deal with the BBC, I believe. And the transmitter at Daventry was run by the post office, who were in
mm,
charge of transmitting and delivering everything in Britain, including radio. So they looked at this wobble and discovered that the wobble was only present when a metallic aluminium aircraft flew through their beam quite close to the radio station at Daventry. And I read the report. It was part of the post office research. So I thought, I'll go and investigate that.
Oh, that's great. I'd heard about the wobbly signal at the BBC when I worked there and the post office. And yeah. So, Robert, you went to Daventry to look and investigate the wobble?
And that's what we did. We got a van,
Mhm.
and I just got this device called an oscilloscope. You could look at a radio frequency and see if it wobbled. So I thought if I could listen to the transmission and get an airplane to fly through it, maybe I could see the actual wobble on this new thing called an oscilloscope. So we asked the post office to transmit a tone. 1,000 hertz. It's a standard kind of wave. And we got a plane, a big bomber, a metal bomber from the War Office to
Mhm.
take off and fly somewhere near Daventry. And we could see the trace on our oscilloscope in our wee truck in a field quite near the transmitter in Daventry. And as the plane flew through the ooh, it went ooh, and as the plane moved, it went ooh, and we could see the wiggle moving where the plane had attenuated, made lesser the beam. Uh.
Mhm.
So, if only you could have a scale on the oscilloscope, you could work out where the plane was and how far it was away from you. Eureka!
Great. Oh, that's great. Oh, must have been an amazing moment. So, you contacted Tizard and said, Britain has a radio direction finder. I mean, as you say, I mean, they already existed in the Ukraine, and the wobble wasn't your invention, but you made a device that could see the wobble and measure it.
I got onto the typewriter and wrote to Henry
Mhm.
Tizard. I said, I think I could do radio direction finding. Would that be of any use to the war effort?
Which it was. He must have been super excited that you could actually see a plane at a distance. Oh, well done. So, the wobble, Ukraine, you built the British way of measuring the wobble.
Aye, that's how it started. I mean, we did go on
Mhm.
to make it a lot more accurate, but you can't overestimate how much the original idea came from both the Ukrainians and the BBC's and the GPO's wobble. That's where the idea was born.
Oh, that's interesting. I bet the War Office was super excited by your way of measuring where the wobble was. So what happened next?
They were super excited, and so I got my contract when the death rate just extended, and we had to go back to Orford Ness, this time to build what I called radio direction finding.
So you're not a big fan of Orford Ness? It's a bit wild. I heard that down the road there was a stately home which might be a best as a base for a bit of a scientific operation, wasn't it called Bawdsey Manor?
I Bawdsey, it's a big stately home. It was actually in
Mhm.
private hands, but the War Department made an offer they couldn't refuse, and in the end, it became our base. We were very, very happy at Bawdsey. It was overlooking the North Sea. It was just down the road from the secret Orford Nest, and it had all the comforts from home. Well, it actually didn't. We worked in the stable block at Bawdsey Manor, but it was much better than working in a wee hut on Orford Ness.
So, Robert, let's get a bit technical here. Radio, all different electromagnetic frequencies. Did you come up with an idea of what would be a good wavelength to actually bounce off an aircraft and see it at a distance? I mean, long wave, short waves, microwaves. What did you think might work?
You're absolutely correct.
Mhm.
But there was a limitation at the time. We only had kit really from the Navy, and they were in long waves. We knew that if we could move into the microwave band, higher frequencies, we would get more resolution. But the high powered valve tubes that we had of the day to build a transmitter that could send out a radio wave of any type over a long enough distance to make it worthwhile at the time was about 1 meter waves.
Oh, that's really interesting. I get it. So there's no point in making a radio direction finder that sees an airplane above Daventry. You want to see one way over the other side of the North Sea coming towards Britain to give enough warning to actually launch a fighter plane. What was the range that you were told that a radio direction finder needed to work?
Yes, that's exactly the issue. The
Mm.
War Department got in touch with the RAF and said, how long would it take to scramble a fighter plane to intercept, say, a German incoming bomber? And they said 3 minutes, which is incredibly good of them. I mean, that's really snappy of the RAF. But 3 minutes at the speed of light, and that was my task, meant it was well over 100 miles off the coast of Britain. You had to spot the incoming bombers.
Oh, so you made a system that worked at 100 miles? That's quite a long range.
No, we didn't. In fact, there's a wee funny story.
Mm.
Uh, we're scientists and we all work in the metric system, meters. And at first, we only managed to get the radio direction finding beam to go about 100 kilometers. And we sent that as a report to London that we'd got over 100 kilometers, which we were very proud of. But unfortunately, nobody in the War Office understood kilometers. And it was reported that we'd managed to build a radio direction finding of over 100 miles, which is actually like 150,
Mm.
getting on to nearly 200 kilometers. I mean, I can't really do the conversion in my head, but it was not 100 miles. They just got their units muddled up.
So your first RDF, radio direction finding transmitter and receiver, was built at Bawdsey in Suffolk, and it only must have seen over the North Sea. Of course, they might have attacked over the English Channel or the Irish Sea or Scotland or anywhere. So how are you going to protect the whole of the island of Great Britain?
Yes, the first transmitter was at Bawdsey. It was made of
Mm.
wood, and we thought that was great. But you're quite right. The War Office said, what about Brighton? Never mind Bawdsey. And so we decided that we'd have to have a chain of transmitters. And in the end, it got called Chain Home, which was a good name for our radio direction finding system.
Oh, great. The War Office must have put a lot of money into building this. I guess by now it was proved that it worked and you had a decent distance. And now, if you had a chain home of them, you could actually alert the fighters. But how did that work?
I don't take any credit for this. It's absolutely brilliant.
Mm.
As good as our little radio direction finding it was, if it wasn't for the management of the chain home system, we would see blips, but you had to have a system that quickly told the RAF where to go, and that was brilliantly done by the Ministry of Defence with these bases that was girls pushing around little flags of aircraft and direct hotlines and shouting scramble, 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 ding, 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 and Hurricanes and Spitfires would take off.
Mm.
One of the interesting things was we got them in the air before they knew where they were going. So we came up with an idea that they would take off and the flight leader would then contact the communication base. We're told the height and the direction then to fly. But first of all, let's get our boys up in the air. That was really brilliant.
So it worked, and sadly, by now we're actually into being attacked by the Germans in what became known as World War II, and there were bombers coming across the North Sea, the English Channel, all over the place, and it was being seen by your system of Chainham. Absolutely brilliant. Could it be better?
Absolutely, it could be better. It
Mm.
was very much down to the skill of the operator to get the direction, speed, and height of planes. Often the Germans would trick the system, multiple aircraft coming from multiple directions. There was lots of things that would actually make it quite confusing. It could be better. If only we had a shorter wavelength, we would get higher resolution.
Aha, shorter wavelength, higher resolution. Um, Wasn't that what the Ukrainians were doing? Isn't the Ukrainian system that predates Chain Home using microwaves? But I don't understand this whole thing. How do you generate microwaves? Tell me about Ukraine and tell me about their system.
You're right, the Ukrainians use microwaves, but
Mhm.
microwaves are wee beasties. They're hard to generate. And we didn't really have any way of making and propagating a microwave signal. But the Ukrainians did, so I guess somehow Britain got hold of one of the Ukrainian devices. It was called a magnetron. In fact, it was called a cavity magnetron. I think I could show you a picture of the original Ukrainian one once it somehow got back to England.
Mhm.
And it was given to a couple of colleagues of mine in Birmingham, and they looked at the Ukrainian cavity magnetron and wondered if they could build one themselves. So they took it apart and built their own version of it. Again, now that I'm dead, it's lost in the mist of time. That's kind of assumed that Britain invented the cavity magnetron. No, they didn't. It was Ukrainian, and Britain actually made it a bit better, along with a help from France.
Oh, that's very revisionist history. Oh, I'm so pleased I talked to you today. So, what was this French connection?
Well, it was a very interesting French scientist. One
Mhm.
of the problems with a cavity magnetron is it needs to be a vacuum to make the waves actually build up inside the cavity, but then it has to come out into the air. So you need some kind of window on top of the cavity magnetron to hold the vacuum inside but have air on the other side. And that was very, very much designed by a clever Frenchman who came over to London and gave his ideas into material science to the British company called GEC. Not the American company, but a
Mhm.
tiny company in Wembley who were actually very good at building strong magnets.
Oh, great. So Britain built their own copy of the Ukrainian magnetron, and it was improved by the French window design, and it was using the magnets at a company in Wembley. Isn't that interesting? I'm really pleased that you cleared that up. Um, but they seem to have made it really strong.
You're absolutely right, although it probably wasn't their
Mhm.
invention in the first place. In the first few months, GEC and the guys in Birmingham managed to get the power up to the point that we could, see over 100 miles, but this time using the tiny wee waves of microwaves, using this weird, strange thing called a cavity magnetron. Um, yeah, no, they really made it better. Whether it was better than the Ukrainian system, I don't know because we don't know all the peripheral things that the Ukrainians had. But the basic cavity magnetron was made better in Britain.
So this must have been all very secret. Your work and the guys in Birmingham and the cavity magnetron must have been incredibly secret.
It was completely secret. British people didn't
Mhm.
know about it. In fact, they were told a lie, a wee story, that bombers at night, British bombers, could find German airplanes because they ate carrots. Carrots help you see in the dark. That's how we're seeing the German planes at night. Carrots are great for you, I'm sure, but we managed to make the system so compact and so low power, but effective, that you could fit it inside a night fighter. Completely nobody talked about it.
Oh yeah, that's what I heard. I even grew up in the 1950s told to eat carrots because it was good for my eyesight. I didn't realize it was just a piece of misinformation. So how was Britain doing in winning the war?
Uh, Britain wasn't winning the
Mhm.
war. We could see them coming, but we were going to be overwhelmed. Britain was going to be invaded. We were going to lose. France had been invaded, Poland, most of Western Europe. The Japanese were using German types of radar at the time. It was all a mess. If only we could get the help of those Americans who are very reluctant to become involved in a war in Europe.
Well, that's incredibly interesting history, and I definitely know that if the US hadn't become involved in the war in Europe, yeah, we would be speaking German. So how are you involved in that? I hear that there's another secret story.
Either was Henry Tizard
Mm.
decided to give radio direction finding and the cavity magnetron to the Americans to persuade them to come and be involved in Europe. We also gave them lots of other things. We were actually, Britain was doing basic atomic research using a company called Tube Alloys. We also were looking at supersonic, faster than the speed of sound flight. And we shared all that with the Americans to persuade them to come and help us, tiny nation, fight the Germans.
Oh, that's interesting. I guess it worked. Initially, America supplied goods and fuel and stuff before they actually were supplying fighting people. So that would be of great use to the UK at the time. Um, but Americans must have been very excited by your cavity magnetron and radio direction finding. What did they do with it?
They were super excited. They didn't have anything like that.
Mm.
It was really the birth of how good Britain is at physics. I mean, some of it wasn't ours, but anyway, we developed it. And they took it further. They miniaturized it. They had a massive manufacturing capability. A lot of what today, just before I died, is now called Silicon Valley, was actually microwave or radar valley. All those big computer companies that we know today used to make all these microwave devices for World War II. That's how they got there started. They had the manufacturing and the research and design capabilities that Britain never had. And they came up with a wee name. They called it radar. And that's the name that we
Mm.
know
Mm.
today.
Yeah, radar. And the story goes that radar won World War II. The atomic bomb ended it. But if it wasn't for you, Robert, with Ukrainian plans, the death ray, orphaned nest, Bawdsey, radio direction finding, chain home, and good management of Spitfires, we'd never have won World War II.
Oh, I don't want to take any of that credit. I did my
Mm.
wee bit. I think Chain Home was pretty good. I actually put 50% of how good Chain Home was down to management, the way that the planes were actually set in the air after the wee signal was found, and we did make it better later on. But the Americans really developed what they called radar. And today, radar is so important not only to see planes, but to look inside the Earth, to look at distant planets, I hear, and also to find stuff under the ground and to track things. If only you could see radar in 3D.
Mm.
But I'm not around to work on that. But it's been really fun talking to you today. I hope, what is it, YouTube? I never knew what it was, but if I can be of any assistance in the future and clear up some of these wee points, because a lot of people don't really understand what we actually did at the time.
Robert Watson-Watt, it's really an honor to talk to you, sir. I've always wanted to ask you those questions, and what you said today is truly fascinating. I hope I didn't disturb you. This is amazing, isn't it? It's good. So, yeah, I'll share this with something called YouTube, which lets people actually watch you and watch your interview. So, thank you very much, and hopefully we'll speak again soon.